So before I can show you the finished templated glory that is the composite stack class, as well as the templated dynamic memory stack class, I have to talk to you about one minor complication, and that is, how do you have friend functions with templated classes? Okay, so the problem is that you have a friend function, which is a function that exists outside of the class, right? It's just a normal function that happens to have special abilities with regard to a particular class. That's what makes it a friend, the ability to access those private data members and private function members. However, if you have a templated class, it means that there's many different versions of the class, and it means that if you have a friend function, you need to be able to have somehow to match the friend function for each particular version of a class. And there are two ways to handle having friend functions with a templated class. There's the easy way and the hard way, and I'll show you an example of both. So the easy way is you define the friend function actually inline, inside of the class declaration. So the nice thing about declaring something inside of the class declaration is you don't have to specify the angle bracket type. You can just use the type name specifier as if it was a normal type. And the nice thing about this is by declaring your friend function and defining your friend function inside of the class definition, between the angle or the curly brackets for the class, every time you get a new, every time you make an instance of the templated class, every time you make a stack of char or a stack of long, you'll also get a friend function for that particular class. And so the hard way, the ugly way, is to do what's called using forward declarations. So at the beginning of your header file, you actually say, hey, I have a templated class named stack. And then you say, by the way, I want to have a templated function named operator less than. Here is its declaration. Here are the arguments that it takes. And then you can also say, I also have a friend version of this class. And then you actually write the actual body of the class, the body of the function. That's a lot messier, but it does work. And once again, the way that it works is you have to do what's called a forward declaration. Basically, at the beginning of your file, you need to say, I'm going to tell you about a templated class. And then you say, I also am going to tell you about the operator less than, because you need both of those names so that you can use them in later parts of your class. And again, it's a bit messy. I strongly recommend doing the easy version, but you can do this other version if you need to. Okay, well, regardless of which method you use, and once again, I'll show you examples using the stack classes, regardless of which example you use, every time you make a templated version of the stack, every time you instantiate a stack of longs or stack of chars, you'll also get the custom friend function, like the operator less than, that works on stacks of characters or that works on stacks of longs. Okay, so let's show you those examples. Okay, so here is my composite stack. Note that it's now templated, and I'm calling the type that this stack holds element type. And so I want a vector of element type here. And in here, once again, I can say, I have my stack that takes the default, my stack that takes an initializer list. Note this is an initializer list of the appropriate element type. And then most of the rest of the code looks pretty much the same as in the previous example when I showed you using the composite stack. However, I'm using the easy friend function mode here, where I'm declaring the friend inline. I'm declaring the friend inside of my declaration for the stack. See, the stack starts here and ends here. I'm declaring my friend function in here. And so here it otherwise looks much the same. It's a stack that takes an element type. I need an OStream iterator that takes an element type and it does the appropriate output. And then down here I have all of my member functions. And note, because my member functions aren't declared in line, I need to start at the beginning saying, hey, this is a templated member function. It takes expects an element type, and then it uses the element type appropriately to say, I have a stack of this element type, it returns this element type, and so forth. Once again, this looks much the same, except where there used to be chars everywhere, now I'm saying, hey, this is a templated stack. It works on more than just chars. And everything else looks much the same. Okay, so now let's go to the version that uses the dynamic memory allocation, and we'll also do the hard way to specify inline functions. So at the beginning of my program, I say, hey, I'm going to tell you all about a stack that uses an element type in its construction. And then in the next line here, I'm saying, I'm also going to tell you about this function called operator less than that works on stacks of a given element type. And the reason why you have to do this is note that inside my operator less than, I need to use the name stack. So if I put this one first, it would fail because I need to have already told the compiler that stacks exist. And I need to forward declare this because in my function, in order for me to make this a friend, I had to have already said that this operator less than, this function already exists. The exact details, a little bit beyond the scope of the class, but basically you have to forward declare. You have to say that both the stack and this member function exist before you define them. Okay, and so down here we have the actual definition of our stack. Here we're saying it's templated. We have a templated, array of whatever this element type is. Otherwise, this code looks almost exactly the same. However, here, notice that we do not implement our operator less than here. We don't do it in line. We do it down below. But we have all of our templated functions that look almost exactly the same, except they're now templated. Let's go down to where we have our friend functions. We have templated type name element type, and here we can actually define our operator less than way down here. So once again, the big picture here is that you can make your own custom templated types that have dynamic memory allocation. I walked you through how to do that with a stack. However, notice it took a really long time to get to this point. In general, it probably would have been a lot easier just to use a vector and be like call push back and call back on the vector and just use that stack. Or if you really need your own custom type that's called stack and it has methods that have the names that you want, then to do the composite version. Making this dynamically allocated memory with that grows to the particular size and is templated is probably more work than it's worth. And to be honest, it took a whole lot of steps, a whole lot of experimentation, a whole lot of checking for bugs to get to this point.